So now that we've kind of defined heat and what an endothermic and exothermic reaction are, we can now use a notation to represent these chemical reactions. So typically what we say is we have reactions going to products, and if heat is one of the products, or if heat is released, we can say that our chemical reaction is exothermic and our delta H is going to be negative. So we can look at what we call energy diagrams or energy reaction diagrams, and on the y-axis we're going to put our energy, and on the x-axis we're going to look at the progress of our reaction. So in an exothermic reaction, our delta H is negative, or our overall energy is going to be negative. So here we can list the energy of our reactants, and over here we'll list the energy of the products. So we can look at our change in energy, and it's going to be a negative energy. Or another way of saying negative energy is we're going to say that heat must be given off. On the flip side, if we said that we have our reactants going to products, and if heat is one of the reactants, we can say that our particular reaction is endothermic, which means that our delta H has to be positive. So now if we look at our energy reaction progress diagram, we can say that we have energy again on the y-axis, but in this case our reactants are going to be fairly low in energy. Our products, on the other hand, are going to be very, very high on energy. So our energy change here is going to be a positive energy term, and this is telling us that heat must be added. And this is why we would say that our heat in this case would be a reactant. And we kind of alluded to this in a previous video, but I want to reiterate what our first law of thermodynamics says. And that is that energy cannot be created or destroyed, but can be converted from one form to another. And overall, our change in energy is going to be equal to Q plus W. And in this case, Q is our heat, and W is work. So one of the other things that we definitely need to realize, and especially from these diagrams here looking at our chemical reactions, is that here we indicate a negative energy and a positive energy. And we need to remember that if we have a positive value for Q, that means that our heat is absorbed. And if we have a negative value for Q, it means it's given off. Likewise, when we look at the work, if our value of work is positive, that means we have work done on the system. And if our work is negative, it's work done by the system. So we use different notations, and I want you to recognize that in a particular chemical reaction, you recognize what our energy profile would be for the progress of a reaction, whether or not something is exothermic and endothermic, and whether the heat would then be a product or a reactant of a given reaction. So we will use all these concepts to look at the next big term in this unit, which will be enthalpy, and we will cover that in the next video.